So ఇది అయిపోయింది కదా. So we have completed this table. So this one we have talking about. Okay, so I have explained up to here, right? So this is related to the total n count. Okay, so this is related to total n count. It is a similar like how we did the safety population. Same thing. So up to here. So we got 47, which is a test, and 45 would be the reference. Because as per the mock shell, we need to do only test and reference. We don't have any overall or all. Okay. So we give the condition here. This is first condition would be safety population flag. Okay. The safety population would be Y. And the next condition would be treatment emergent flag equal to Y. Okay. These two conditions we have applied because this table is related to emergent adverse event, treatment emergent events. Okay. So for that reason, we have kept treatment emergent flag equal to Y. Okay, then we have created the treatment TRT variable, the same like we have done. I think it's demo 3. Okay, so yeah, the same process. We have created the treatment to find the the counts. So here you have to observe two things. So one is AE bodices, another one is AE decode. Okay. Yeah, one minute. Huh? Sorry. So here you have seen the two variables. So one is a system organ class. Okay. The next one is preferred term. So you need to classify your table, based on the system organ class and the preferred term. In general, how in ADE data sets, AE bodies will be considered as a system organ class and AE decode will be preferred term. So if you check the specification here, so you can see in the ADAE, I need to go to the HDTM one. So if you check, we see here AE bodies, which is a body system or organ class. Okay, so we don't take the code. Okay, we don't take the primary system organ class. It's just a body system organ class. So this is the one we usually consider for system organ class, to display. So this is also very important in the interview question. They will ask you for a system organ class, what is the variable you take from the AE dataset? This come from SDTM dataset. Okay, AE dataset. So you should say AE bodices and AE decode for preferred term. Okay, so if you check the AED code, so you see here they mention as dictionary derived term, which is also kind of we call as a preferred term. So the preferred term code, this is code we don't consider. We consider only AED code. Okay, this is the one we consider. Okay, as per that those variables, I have I'm keeping only Unix subject ID, AE bodices, and AED code, and the treatment this one, and I have created the order variable. Okay, I'm giving the order. Okay. Treatment emergent flag is uninitialized. So why is uninitialized? Okay, let me check the ADA. It seems there is no variable inside. One second, I'm just checking. We have mentioned the treatment emergent flag here. Then why is not here? So we got here TRTM and so we got TRTM. So, not sure. Why is TRTMFL? Okay. So I just take this one. Okay, now it's good. Alright, so there is a smell mistake for the variable, so that's the reason it's showing some. So we got, the.
Well,
Okay, so we got AE code, AE bodices, and the treatment and order. Okay, and the Unix subject ID. So these are the ones, these 5 variables we have kept for keeping variable. Okay, so in the keep we have kept only these 5 variables. So thereafter, so we have applied the condition. Okay, we have applied the safety population and the treatment emergent flag. So we got this table. So then we need to apply the counts. Okay, so initially we need to do this one, the number of subject with the treatment emergent adverse event. Okay, so I'm creating the new table, create table, and the selecting the TRT and the count of unique subject ID as n. Okay, then the number of subjects, I'm giving the labels as AE Boresis. Okay, so I'm just creating this label. I'm just creating this label as a AE Boresis, and length I have given 200 from ADAE and the group by TRT. So group by TRT. Okay, then that is for the first one. Okay, that is for the first part of this one. Okay, the next, so I need to do for the system organ class. Okay, so I have created the table, the treatment, which is AE Boresis, which I have to select. Okay, then count of unique subject ID as n. So the unique subject ID you are counting based on the AE Boresis. Okay, so here you are counting based on the just treatment emergent adverse events, which is total one. So here you base it on the system organ class. Okay, then you group by, you see, treatment and AE Boresis. So this is very important. Okay, this is also very important if you need to apply to select the counts as per the system organ class. You have to have this step, is very important. And the same goes with the preferred term. So you apply the AE Boresis. In the AE Boresis, you have to take the AE decoder. Okay, and this is also very important. Okay, why we have select AE Boresis here? The reason, because in the gastrointestinal, which is system organ class, right? And the nausea, diarrhea, vomiting, those are the preferred terms. So those preferred terms consider for gastrointestinal system organ class. So that's the reason we have taken AE Boresis, AE decoder, and this is very, very important step in this whole table. Okay, if you forget this one, you won't be classified. Okay, so you have group by TRT, AE Boresis, AE decoder, like that you have to do it. So here the count you're calculating based on the system organ class, based on the treatment, system organ class, and the AE decoder. Okay, you're selecting those kind of grouping by. Okay, so this is very important step. Once you're done, okay, you see, I'll show you this. So now you have created 3 data sets. Okay, 3 data sets, SOC, preferred term, and anyone has created. So if you check anyone, this is a count based on the test, or treatment, because we don't have any reference. We have only test. So that's the reason it's showing only one. So here AE Boresis is a number of subject with the treatment emergent adverse events. Okay, and if you open to the SOC, so you see here is based on the treatment as well as system organ class, gastrointestinal, nervous system, how many counts, like 1 count, 2 counts. So you have calculated like that. And if you take the preferred term, so this one you have AE Boresis and the treatment, and this one is a preferred term, and how many counts as per the preferred term, one, like that. It is classified.
Okay.
So after this one, you set all of them, because here is not merging, is not set. Here is vertical, you are combining, right? You are setting only, so you're not horizontally combined. So for that reason, you have set all these 3. Then you sort based on the system and the preferred term. Okay, then you sort. Okay, you sort. Okay, when you sort, if you see the this website, this data set, so you have the system organ class here, and you have AE decoder, which is the preferred term, and we don't need this one, which is temporary, and these are the counts. So on the first one we got it. The second one is system organ class, which is that preferred term. Okay, and the gastrointestinal, 2 of them, so one nausea, one vomiting. So like that it has classified. Okay, after we got the counts, we need to do the percentage, the same thing we have done yesterday. So you take the all, so you have, if it is missing, you apply it directly, 0 count. There is a space. Why we have to give the space? Because it needs to be aligned. It needs to align with the count. So that's the reason they put the space. Then if it is, if the test is the same like, total count, then you have to put directly apply 100% along with the counts. And if it's not, then we have to put the percentage. Okay. And you do the same thing with the reference. Okay. And here is one more important step. If AED equal to missing, because you see here, so the Madras system organ class on the top and the Madras preferred. Okay. So they're one by one each other, right? So, but there is a space between, okay, sorry. So there is a space, even here also space. Okay, system organ class come on the top, and there is a space. After this one, you have to get the preferred row. Okay, so for that reason, we cannot, so we cannot represent like that, because here, one second. So this one we consider as AE body cis, and this one AE body cis 1. So we need to instead of overlapping, we're just creating as a new variable. Okay, if it is equal to missing, and if body cis is not equal to missing, then AE body cis 1 equal to AE body cis. Okay, else AE body cis there is a space, then AE decode. Okay, I'll show you this difference. So if you run the final thing, now you see here, now you see the body cis 1, there is a number of system organ, and here you see the system organ class along with there is a space and blurry vision. This is preferred term. So we have to represent display like this only. So here the system organ class, then is a preferred term, and there is a space between. Okay, so we got the percentage here, the total counts and the percentages for each individual one. And the reference we all have 0, so we don't have any related to the reference one. So only the test one we got the adverse events. Okay. Okay. So once we got the structure, so we can do, so we can do the report part in this one. So here I take the final, which is this one. Then I applied, all those options. Then I took the AE body cis, AE decode, and AE body cis 1. And as per the Moxel, there is a line after the treatment, so it has to be centered. So I applied that code here. Yeah. So AE body cis should be no print, because we just take as consideration as sorting only, and AE decode also for sorting only. Okay. So the only part we get in AE body cis 1, because when you check in the final data set, so we need this variable. We don't need those variables, because these are the one we have to represent in the report. Okay. So for that one, we just take in as a no print. We just need for sorting purpose. Then I have applied the AE body cis 1 here as a Metra system organ class, Metra preferred term. I have given that, the label. Then I put this left alignment, and this one the display, which I applied, center alignment, and I have given the end count here. So each system organ class, I put the space between each one. So once you've done this one, so when you open, okay, you see here the total count is 47 and total count is 45, but we don't have any adverse events here. So most of the adverse events we got from test drug. So the number of subjects with the TAT, which is 6. Okay, total is 6. And eye disorder, how many? Just one patient. And the gastrointestinal are 2 patients. And the nervous system is, one patient. The skin is 2. So when you count, the total is 6. So 1, 2, 3, 4, 5, 6 counts. Okay. So like that you have to calculate. And in the 47, how many percentages? 12.8%. Like 47 is 100%, and 6 is how much? 12.8%. So like that you have to check. You have to double check with your and you check the spelling mistake. Is there any spelling mistake here? And check the any footnotes missing and the date. So you have to check each and everything before you go for QCR part, the QCR thing. So for the reference, we don't have any adverse events, so we just keep it as a 0 counts. Okay. So far, do you have any doubts?
No, Ali.
Hello.
No, Ali, I'm good. I'm good.
Okay. Sorry, I heard something. Okay. So today, the one more table we're going to talk about, which is the vital signs. Okay. So this table quite is not quite difficult, but is almost the same thing how we perform the first one, like here one median, how you perform the statistics. The only difference here, so you have to represent the this is a vital sign. First of all, this is vital signs. So we have to display the parameter wise. Okay, system blood, diastolic pulse rate, those ones. And so each parameter we have to display as a visit wise and a time point wise. You remember the time points, baselines, 0 hours, 2 hours. So that one, and we need to calculate baseline, the statistics, summary statistics for the observed value. Okay, and for the test and for the reference. Okay, so this is aval value, and this is change value, change from baseline. So here the baseline we don't have, change, the formula, right? Change equal to aval minus base. So if you keep aval minus base, you will be get zero counts here. So that's why we don't display these ones. So we only display after the drug administration, which is the post baseline. So this is the post baseline values, which is the change values. Okay. So you have to repeat, you have to do this summary statistics for all 4-5 parameters. Okay, so we have diastolic, temperature, and pulse rate. So we don't have any height, weight, BMI. So we don't have those ones. We have only 4 parameters here as per the mark sheet. If they ask you to represent, because the height, weight we already apply here. So because we don't have the vital signs, after the post baseline, we don't do any kind of. We just consider before in the screening stage only. That's why I have mentioned here. For post change from baseline, if you need to show the display in the report, we just consider these 4 parameters. Okay, so this is the one of the one of kind of most important in the vital signs one. Okay, so we're gonna go one by one each. Okay. And almost like 90 to 100% the vital signs structure would be similar like this.
Normally, Ali, in general, say for study, how many tables we'll be creating?
Yes, it depends on the studies. If some studies, they go maybe 60 for 1 year. Okay, for 1 year the project would be, and if some studies they may go more. I mean, they may go more than 200 to 300. It depends on the study. So I'm just telling you like the basic structure. For example, in adverse event. Okay, in adverse event, this is one of the table. So you may have in adverse event 10 to 15 tables, but they only change few things. The variables they will be changed. The structure would be the same, but they will be changed. Like the severity thing. They may add. The age is less than 30 patients. Those patients, you have to create one table. Age is greater than 30 patients, you have to create the table. If it is more severe, what are the severe classes? So they divide the table like that, and every time if you have a condition like that, you just change the condition and you apply the same code and you submit for for QCR thing. The QCR also develop the program simultaneously, and he cross-check with your table, and if he has any observation the data values mismatching, he will be let you know. Okay, he will let you know by tracking. Usually in the Excel sheet, he will give you the comments that the particular variable has, the length has truncation, something, any mismatches if he found, he will let you know. Then you modify yourself on your side, and then you send it back to him, and he will, revalidate everything. And once it's done, you can save it as a list here in your folder. Okay. And in between, if you want to change, when they do the submission, the client will check, and they do, and if they want to change the condition, and they will change it. Instead of less than 30, they want to change less than 25. So you need to come back and you modify your program, and so it is a process. It does like that. Until they wants to satisfy and everything is good for FDA review or PMDA, whatever it is. Until then, they keep doing the same thing, repeat and repeat. So in your first 6 months, you will find more kind of difficulties to understanding what is going on. After that, you will be the same thing you are repeating. Okay, so the same process. Okay, so let's start with this table. So vital signs is RLVS. Okay. So I change this thing. So, up July. Yes. Yes. Okay, up to here, right? Okay, so the next part would be the big N count. So we have test and reference only, so we don't need any all counts. But anyway, I'll take this one. I'm taking the treatment related information from the ADSL, and this is also safety population. So I kept the safety population filter. Then I created 3 instead of 2. I created 3 anyway. So we at the end we're gonna inform only 2. So we don't need so we keep only 2. So we don't need to one second. So I just remove this part. Okay. So we got 47 and 45. 47 which is a test, and 45 which is a reference. Check if we have any mistakes. Okay. So we got our N counts, big N counts. Okay, so this part we got it. These 2 part we got. Next we go to the parameters. We find the statistics. So first we need to align, bring those parameters you needed. Okay.
Lily, can you give me just 1 minute, please? 1 minute.
Yeah, sure.
No. Come. Le. Come. That's okay. That's okay. Sleep. Go ahead, Ali. Sorry.
Oh, it's okay. Okay, so next one, after getting the big ends, we need to do the small end right now. Okay, so in order to get the small end, we have to get from the vital sign, right? So prox or data equal to. So I'm bringing from Adam dataset ADVS. Okay, so out equal to. Either you can use the dataset. It's up to you how you want. So here I'm gonna keep only the required variable. Okay, Unix subject ID. I need a param n, which is a parameter, because in order to sort, I need a param n. And the a visit. Okay, so visit parameter visit. Okay, then time point wise ATPTN. So everything from the adverts event. I mean everything from the Adam dataset. Okay, that's why it has a. Okay, we have to take from everything from ADVS. Okay, not from the VS dataset, from the SDTM. Okay, so then we take aval is the value we needed, observed value. Okay, then we also need to change from baseline, right? So this value we need this one. Then treatment here P AN. Wait, I'll show you here in our okay, so it seems like we haven't done this part. Okay, so we haven't done the treatment related part. Shit. Let me check.
So my question is, so we did not do treatment because when when we got a specification sheet for Excel, maybe treatment was permissible variable or permissible variable. That's why maybe we did not do it. When they created specification sheet that it is as permissible variable, and then do we get situations where they'll be asking in the tables?
Well, if you don't see in your program, I mean in the Adam data set, if you don't see that particular variable, you need to ask the Adam people. Okay. Perhaps they forget in the specification, or I mean they forget that the variable or in the specification, or maybe they haven't done that, that they're missing that macro variable. So somewhere they will be catch easily if you miss something. So if you don't have this variable, the treatment, the actual related information, so we need it here because we have to represent, right? We have to represent the treatment related information.
That's what my question is. Like the tables is saying that we need that variable, but in the specification sheet that variable is not included. So
So you need to ask Adam people.
Does this kind of situations normally happen? Like,
yeah, it happens many times. Yes.
okay.
Yeah, it happens many times. So you need to inquire with Adam people. If you are doing like tables, listing, and figures, you need to ask Adam people. So we got here TRTA, TRTAN. So I just upload those ones. So this one. TRTAN, TRTA. Okay. So once you keep all these variables, so you sort the unique subject ID and param wise, okay, and a visit wise, then ATPT wise. Okay. Sort. So here the condition is where aval not equal to
That
missing and param n not in 1 comma, sorry, there is no comma. So 1 2 3, because why 1 2 3? Because we don't need height, weight, and BMI, so we should.
yeah.
So here in the param is height is 1, weight is 2, and BMI is 3. So we don't need this information. So for that reason, I'm just filtering here only. So what are the summary statistics you do? You will get here only, okay? And say FFL equal to 1. Remember, when you're doing in the ADVS, when you do in the ADSS filtration, you also do in the ADVS also. ADVS level. Those population only you need to apply the statistics, okay?
I think the